Good morning. Thanks for coming to my talk about autonomous vehicles. I definitely will not fill up the entire hour and a half slot, so just preparing you, it'll probably be about 45 minutes, and I'm going to talk about a few of the ways that HyPACK supports different autonomous vehicles, and then I'm going to talk a little bit about our new Lidar payload, which I don't know if you've seen it, but it's our prototype unit has been sitting in our display booth, so if you have questions or want to take a look at it in person after the talk, feel free to come over and I can show you the unit. I hope everyone's had a good week. I think it's pretty hilarious that there's some sort of senior a cappella convention at the hotel, and I tried to convince a group of guys I met last night to come give a singing intro to this talk, but it looks like they're standing me up, so do it the old-fashioned way. Okay. So what are unmanned systems? I'm sure you all obviously know. There's a bunch of them in display in our convention hall right now, but there's three main classes: drones, surface vehicles, and underwater vehicles. HyPACK is probably the most involved with surface vehicles because we help integrate a lot of different sensors and write drivers to support their autonomous mission capabilities, and then we can also support Lidar sensors. So if you would like to use HyPACK on a drone for Lidar surveying, we have the capability to do so. And I'll show you a few of the special applications we've developed to support surface vehicles, and maybe talk to you about some sensors that we support that you weren't aware of, and show you some improvements to some of our drivers that we've made over the past year. And as more and more vehicles come on the market, it's hard for us to stay current. So if you work for a manufacturer, you're interested in working with us on some of our drivers, please come talk to us. We're always open to improving our drivers and trying to make them better and to support more instruments. So what does HyPACK do for these vehicles? Mainly sensor integration, mission planning. We combine GPS and Autopilot systems to support autonomous data collection, and then we've built in a lot of indicators so you can monitor your system health in real time, and then of course data acquisition and processing. Here's one of the underwater vehicles that we've been involved with. Some of our sister companies that are companies within the corporation Xylem. One of them has a booth here, ISS and YSI and Sontech, and they have partnered with L3Harris to produce this Ivor 3, which is an underwater water quality vehicle that has an ADCP and some water quality sensors that slide into the top here. And they also have a side scan that can do interferometric bathy. And while our software is not used for autonomous mission planning, this vehicle uses software from L3Harris. We've worked with them a lot on integrating these sensors and helping with data processing. And then this is luck that all three of these manufacturers happen to be here, because this is a presentation from last year, but here are some of the companies we worked pretty closely with to help develop drivers. Teledyne has the Z-boat, which is a autonomous multi-beam boat, and then C4 Systems. They have a few different models. I'm sure you've seen their booth. They have some larger catamarans and then some smaller systems, and you can sort of pick and choose what instruments you want to put on your C4 Systems boat, which is really nice. You can customize those to your liking. And then C Robotics, who's also out here in the lobby. Some of our sister companies have partnered with C Robotics to produce a boat called the HyPACK, which has an ADCP and again some water quality sensors and a side scan. And then C Robotics also has a lot of different models. They have some boats where you can put side scan, single beam, So there's quite a few different options. And then there's also Martech, I think, is here, who has some different autonomous boats. And then, oh man, the company from Norway, Otter Maritime. They're here as well, and they also have some really cool different vehicles that you can customize, and they come in all different sizes, and yeah, they're worth checking out. And one of the interesting things about all these vehicles, and it's been fun working at HyPACK because we get to play around with a lot of these, and they all have different ways they communicate. Some of them communicate through like long-range radio systems and antennas, or some of them communicate through Bluetooth chips that'll route through your computer and then the controller. So even though a lot of them have the same capabilities, they all handle really differently, and yeah. Okay, so I'm sure you guys are pretty familiar with a lot of these tools, but you can do your mission planning for autonomous missions in HyPACK using our border editor, our line editors, and then we have a lot of drivers to support different autopilots and proprietary navigation systems. We support, or you can upload a lot of different line planning formats in the HyPACK as well. If you don't want to do your line planning in HyPACK, we can support the GPX format, so even if you want to do your line planning in Google Earth or something, you can upload those in the HyPACK. MAVLink, which is an open source format I'll talk more about in just a second, and then the Teledyne line planning format, and then this one I don't know much about, but we can support it. Yeah, so you can export your mission plan from HyPACK or upload those directly into our line editor for editing, and then we have some line report tools that give you time estimates for surveying based on your line distance and survey speed. It just does some simple math to help you do some survey planning. And then we've done a little work with the FAA charts. If you're doing any drone work, you need to look at these charts and learn how to read airspace and get familiar with those regulations. And there's a few classes that can help you do that. And if anyone's interested, we have some experience in these classes and insurance and stuff, and we'd be happy to chat with you about that. So what we mainly work on in HyPACK to support autonomous vehicles is our interfaces to support autopilots. So when you have your autopilot and the GPS hooked into HyPACK, you can run your mission completely autonomously without user input. Ideally, hopefully, that's the goal. And these drivers just use standard NEMO comms to communicate between all your instruments and the GPS. And then we have some alarms built into our autopilot drivers that give you position, attitude, basic system health. Yeah, so you can track your vehicle as it plods along in its mission. We also have some tools like the adaptive line planning tool, and this is created for multi-beam surveying, but you can put in your beam angle and just the general distance you would like between your survey line, and it'll follow your swath and draw a line as you survey. So as soon as you stop logging, a new line is generated. So you don't, yes, hopefully this can help you reduce data gaps and get some tight coverage if you want. If you want to adjust your survey in real time, this is a good tool for you. And I think I would like to get more feedback on this driver so we can help improve it. So if anyone uses it or has feedback, feel free to give that to us.
That handy for the driver, does that have like parameters that have to be established before you start using it?
Yeah, you have to put some input parameters, and you just set that up in hardware. Did you have a question?
We did a nice sounding better article on that.
Okay.
And I used it with the USGS. And like you say, there's some tweaking, we've got to enter some parameters, but once we get it right, it's really good.
Yeah, great. And I think it gives you a chance to preview your lines too before you accept it. So if you don't like how the driver's performing, you're not locked into that survey line. But yeah, if anyone's curious, Sounding Better articles, they're all on our website, but you can also just Google, do like a quick word search, and that usually works really well. If you Googled Sounding Better adaptive line planning, it would link you right to the article, and that's usually what I do when I need help with HyPACK, or don't call people in the office, I Google it first. Okay. We also have this remote viewing platform tool, and you can access this right through the shell. You need a strong network connection, but you just enter in the IP address of another computer, and you can view your mission and manually control logging. You won't have a lot of options to interfere or change the mission beyond that, but I know a lot of our dredging companies use this so they can see what's going on the survey boats or another barge, but it's great for autonomous vehicles. I've talked to a lot of folks that use it for like ROV dives and stuff, so it can be a great tool for that. But again, you need a strong network connection, so just be aware of that. We also have the 3D point cloud, and this is mainly, I'm going to talk about this for Lidar, but yeah, we have high density point clouds, and it gives you a few options on how you can view your Lidar data, and you can also do some editing in our 3D point cloud as well. But yeah, you can view your data, depth, elevation, intensity, if that's being recorded in your Lidar data. So it's a really great tool, especially for AUVs, but if you want to do some work with like Lidar mounted on your surface vehicle and you don't want to look at the data in the matrix, this can be a great tool.
Oh, hang on, if I can add too.
Yeah.
Like if you have a multi-beam system too combined with it, like it will show those data sets inside of the cloud as you record. So.
Yeah, so if you just want to look at your data, or your multi-beam data in a different way, feel free to check out our real-time cloud.
It's definitely the most user-friendly sort of
Yeah, it's just like
verification check, like you're recording good data, that's an easy way to check. So.
we can also, I've mentioned this a couple times already, but we can also support some water quality data. Mainly, we created these to support some of our sister companies within Xylem, but yeah, if anyone's interested in this, I'd be happy to put you in touch with the YSI folks, but we can support, I thought we could support up to 16. This might be an old slide for these. But we can support a lot of different fields, and then we have some pretty cool processing tools for water quality data also, so you can do some modeling and some graphical analysis for these. I'm actually going to jump out really quick and show you some of the work that we've done to improve our MAVLink driver. So if you folks aren't familiar with MAVLink, it's an open source format. It's super popular for autonomous vehicles because it's open source. The software you can use to support MAVLink mission planning is free. It was created for drones, so it has a lot of features for drones and autonomous aerial vehicles, but a lot of surface vehicle manufacturers are using this language for their autopilot language, like C4 systems, and then most manufacturers are using this command language or slightly adapting it, so it's sort of the most important driver we have for our autonomous vehicle work, and we spent last year trying to update it and improve our MAVLink driver. So I'm going to show you a very basic implementation of our MAVLink driver. So you just access it here in the hardware function. And if you click setup here, this is where you can upload mission, or if you're creating your mission in a third-party software like we talked about earlier, you can download it into your hardware settings here. And then launch this. Hopefully it doesn't freeze. Okay, so here's what the basic driver would look like. And we have a few new features. You can set your launch position, which is your home position. Yeah. And then you can start your mission from the MAVLink driver, or you can choose to start at the nearest waypoint, and then there should be a box that popped up. I probably already have that setting populated where when you end the mission, it'll end it at the nearest waypoint and loiter, or it will return to your launch position. And then we have these parameters available: cruise speed, cruise throttle, turning radius, and waypoint radius. And you can, when you hit get params, it should retrieve these parameters from the vehicle. And you can also set your ideal params and hit set params, and then it should send those parameters to your autonomous vehicle. And then we have some GPS indicators down here. So I don't know if anyone saw the previous iteration of it, but we've added quite a lot of features. So yeah.
And if anyone does use, the driver, they want some sort of parameter added to it, it's not very hard for us to do. So
Yeah.
Just let us know. Talk to us. We can figure something out. So.
Yeah, there are some challenges. Since it's an open source software, the libraries can get updated quite frequently, and sometimes when that happens, like old commands aren't supported and you need to fix something, or new commands won't work properly because something in the library has changed. So it's definitely something we're trying to make an iterative process, and if you have specific comments or questions, please talk to us about it. Okay. Yes, so our data converter tool, we can convert a lot of different data types for processing in HyPACK. So for the Ivor 3, the underwater vehicle, I know that they like to do some of their processing in HyPACK. And then if you're collecting your Lidar data in HyPACK, you can log it in HSX for processing. And then we can save our Lidar data out to a couple of more common data types like LAS and XYZ if you want to do processing in some other programs. We have this tool that's accessed right in the Utilities tab in our shell, the Data Splitter and Joiner, and this is really great for autonomous vehicles as well, because you can remove turns if you have any bad or wonky data that you collected over a turn, you have some beam spreading, or you just want to create nice traditional looking track lines. You can edit out the turns here and then resave a continuously logged file into some nice track lines. We have MBMax and SBMax, which I'm sure you're familiar with one or either or both of them, where you can process a multi-beam, single beam, side scan datas. If you had a mission where you collected multi-beam and LiDAR together, you can save them in MBMax into separate files and edit them separately. There's also some other really cool stuff MBMax can do. You can embed images collected with autonomous vehicles or data correlation, so you can geo-reference image, and you can merge like XYZ or LAS files with multi-beam data to combine LiDAR and multi-beam data into one nice continuous data set. And then we have our new auto processing feature, which you've probably heard about this week. So you enable this option through the shell, set up your read parameters, and then as soon as you stop logging, the read parameters are applied and the HS2X file is available to use. So if you doing some autonomous mission or just need to QC your data quickly, this can be a great tool. You do need to process multi-beam files. Well, it can't process files with multi-beam and LiDAR data collected together. So if you're running a mission with LiDAR, you might want to think about how you want to structure your survey before using this tool. But we're hoping that it can be great for autonomous vehicle use.
Yeah, and I don't know if any of you guys went to the multi-beam courses yesterday, but I think Mike and Joe Burnett both talked about it. But you can set up like a set of the filters in there. So if you have some sort of like baseline thing, there are certain filters like even beaming or something like that. You can do all that stuff and just have that already filtered out when the auto processing is done. So it can sort of save some time, and it saves it in the HS2X format, which is a lot quicker to load. So it is something that if you're doing it on the fly anyways, you might want to look into trying to set that up. So.
We also have this pressure smoothing option in MBMAX, so this is mainly for underwater vehicles. I just want to bring your attention that this tool is out there. One of the only specialized filters we have for LiDAR data is a vegetation filter tool. And this is mainly just to help either filter or focus a data set if you're trying to do some sort of special analysis. So it interprets the lowest minimum elevation in your data set as ground level, and then does some basic correlation to try to map the different vegetation heights. And you have three main controls for this. There's the window size, which is the long profile segment distance, the overlap percentage, which is window segments, and the gate size, which is just like setting a gate if you're editing multi-beam or single beam data, and then it filters data outside of those gates. So this is an example of this filter deployed for use to look at some different like bare earth or ground analysis. We've had some folks that have used this when they're trying to look at or do some beach erosion work, and we're hoping it could be a great tool for people if you want to do some work in a construction site quarry or need to look at some different volumes. You can also import GeoTIFFs into real-time cloud to color your XYZ files with RGB color bands, producing a nice realistic looking point cloud. So this is a great tool for autonomous LiDAR applications. Then you can process water quality data in SBMAX. So you need to set the device field and read parameters. And I have the two data types highlighted because this is an old slide from last year, and the programmers have been working so you can load a lot more than two data fields at one time. But in SBMAX, you can view these data sets as simple spreadsheets. You can edit data, you can do some filtering, you can look at different spikes, and then you can save these data sets out as EDT or XYZ data sets, and then load them into TIN model to do some cool graphical modeling, or load the numerical data set back into your charts if you want to do any sort of analysis that way. But yeah. We're hoping to get a little bit more involved in the world of water quality, so if anyone works in water quality or has some interest in this, please come talk to us. Well, this is another example of the temperature plot of the survey area in that cross section. And this data was collected by the HyPACK, which I mentioned earlier, and is out in the lobby if you...
Turn left onto East Independent Drive, then turn left onto South Union Street.
Okay, now I'm going to talk about the payload a little bit. Some of these slides are going to be repetitive, so I will breeze through them as quickly as I can. Yeah, and then probably be done in about 15 minutes or so, so plenty of time for questions. So a lot of you were probably familiar with the Nexus 800, our drone, and the reason why we decided to move away from the Nexus 800 and more towards a payload, it was becoming really difficult for HyPACK to support the drone itself. Anytime there was some sort of mechanical problem, we were trying to work with a small company in Canada to address these issues, and we don't really have the in-house capability to make those repairs, so it was really hard for us to support our customers. So we want to stay involved with the Lidar, or working with Lidar, but wanted to get away from actually selling drone technology. Plus the world of drones will continue to get more complicated as different regulations come out and different need for insurance and all sorts of other stuff. So we're hoping this is a much better solution, and we are happy because it's a solution that's agnostic, so you can pretty much choose your own drone or put this instrument on a boat or on an ROV or a car or a four-wheeler. So it's a way for us to support people interested in Lidar without having to work with a drone. And the technology in the drone market is changing really rapidly, and so there's a lot to stay on top of, and we're trying to keep current on all the different products in the market. So if you're interested in using this on a drone, I have a list of companies that I know about that have drones large enough to support like a payload of a couple pounds, and then most of them are actually American companies, because a lot of people have problems buying products from DJI because of data security issues. So if you're interested in that, I'd be happy to share that with you. But yeah, so why are folks so interested in Lidar? It's a quick and accurate way to capture data that's sometimes cumbersome and dangerous to collect. It can pick up thin-edged features like utility lines or sides of buildings that photogrammetry has a hard time doing it. And I know the photogrammetry analysis has improved a lot over the years, but you often have to do some time-consuming processing or do multiple passes. And with a LiDAR scanner, even though it's more expensive, you can get that data quickly with one pass. LiDAR can also penetrate through vegetation and forest canopies a little bit better than photogrammetry, and it already integrates really well with our hydrographic equipment. You likely have everything you need for a LiDAR survey except the scanner itself. You can plug it in HyPACK, you can use the GPSs you already have, and there's very little processing, so it should integrate into our workflows really well. So overall, increasing efficiency and reducing risk and getting some pretty cool data. So similar to what we already talked about, you have all the same tools available to you for a LiDAR survey. We've chosen to use SVG hardware for our INS and GNSS systems. SVG, who is also an exhibitor out in the lobby, they have some really cool, super compact, small INS systems. So for the Nexus 800 and the payload, the payload has an SVG inside of it. So we just took SVG and your Velodyne scanner that we're using in the payload into HyPACK, and it's the same process for conducting a normal hydrographic survey. You can set up a matrix to see your coverage in real time. You can monitor your GPS health. We have a couple different drivers, so you can monitor your data quality with your Velodyne. It should be a really similar process, so pretty easy to start up if you're interested in getting into Lidar surveying. Yeah, so we have a driver, so you can look at your topographic laser display where you can monitor elevation readings in real time. And then all of the, the same values are available for monitoring in high sweep survey. One of the best tools we have available is the real-time cloud, so you can see your georeference and motion-corrected data as it's recorded. You can set your display colors to show intensity or depth and elevation, and you can mark targets in real time, set up a target database. When I used to work as a survey tech on one of the NOAA ships, and we were just getting into using Lidar to do shoreline mapping. So we had a Lidar mounted on the cabin of our boat, and we would drive around at somewhat safe distances at certain tide readings, and try to get like heights and elevation readings and positions on some of the features we were interested in, which was mainly just like hazardous rocks or anything that could be dangerous to mariners for charting. So we would drive around with our Lidar and open real-time cloud and just really frantically try to like set targets on whatever rock we would see, and then just do a second pass if we felt like we missed everything. But it was really great because after that we had all of that data saved in HyPACK, and you could export that as a spreadsheet, and you had the position of all of those features with a height reading and a position. So it can be really great for shoreline mapping, and there's lots of other applications for this. We have the remote viewing platform talked about, the data splitter joiner. So if you need to process your Lidar data, do a patch test, which Joe talked about at length yesterday. You're going to do that all in NB Max. If you want to apply filters, edit flyers, or perform any additional sensor calibration, this is the engine you need. So to run a Lidar survey, you do need a HyPACK Max high sweep license that will give you access to this software module. Lidar editing should be pretty simple and a lot less time consuming than hydrographic data. Once you have your patch test values set, all you really need to do is just edit any erroneous data points or apply any S-bets. You can also smooth your GPS data, which should be pretty easy. The Lidar data should be a lot cleaner than spikes you would see in a multi-beam or single beam survey. SVG does recommend filtering GPS data. Their recommended code is the narrow lane RTK, which you can do here just in your read parameters in the GPS tab. As you see, enable accepted GPS modes, and then put a 7 in that box. And then if you want to set up any other basic Lidar filters, I have this image on the right, but that's where you would put that in. We have the first line, you see corrected depth or elevation, and that would just keep your data within a minimum and maximum elevation, especially if you're doing an aerial survey. This could help you figure out like what you want to focus your survey at a certain altitude and make sure you cut out data that you collected while the drone is ascending or descending. This is where you can set up those filters. Yeah, it's important to note that unlike sonar data, you can't interpolate between Lidar data, so if you do have to edit out some data spikes, you're likely going to create a gap, so it's something to be aware of. And then you can use the pitch and roll, tide, and the speed window to edit out any spikes, check for proper elevation, look at data from the IMU, and QC flight speed. I talked about the vegetation filter. We also have a newer tool that came out in 2019, the stockpile volumes tool. and it can compute the volume of an area just using a simple border file. So it will calculate volume based on a data set and a border file, and then give you this output report with volume, void, and perimeter. So it's simply just doing like a tin-to-tin interpolation to get those data files. But we're having folks that do some surveys at construction sites or different quarries that ask for this tool, and one of our programmers worked on it this year. So it's available for you in the tin model tool. Talked about this. We have a few different exportable formats for our LiDAR data. You can export LiDAR data in a DXF for loading into CAD, and then the point cloud colored by the RGB files. We also have a portable web cloud format, so you just need a web browser. It's just an HTTP file, so you don't need HyPACK to look at this data. So if you have a client or someone who just wants quick access to the data without having to use fancy software, we have this option for you. Okay, so I'm going to talk a little bit more specifically about the payload features. So as you can see, it's an enclosure. It has a Velodyne mounted on the front of it, and then some extendable and retractable antenna arms that should snap into place, and the antennas will be at a 1 meter calibration. And the reasoning behind this is that you could, do your GAMS calibration just once, and then you wouldn't have to do it every time you set the instrument up, which is something that we realized with the Nexus 800. Every time you use the instrument in the field, you had to recalibrate it. So we're hoping this is a great asset for folks, so you don't have to waste time doing calibrations. And then the arms fold in to hug the sides of the system for easy transport. Inside the unit, there's an SVG Ellipse 2D compact INS that's RTK compatible, and that's hooked into a mini PC, a Pico 500 that runs Windows 10 and HyPACK Max High Sweep. The computer and the SVG are mounted on a little rack, so if you needed to get into the back of the system or access the computer, you could undo the back panel and slide that out and have pretty easy access there. And then we also have an internal battery that is just chargeable via like a wall of 110 AC watt wall charger that has a 3-hour runtime when it's fully charged. So we're hoping this is a really great asset for folks that just want to bring this in their boat deck, and they don't have to find a way to power the system via their computer rack. And then it can increase the mission capacity if you want to use it from a drone, because it's not drawing power from the drone batteries, and it can give you more time in the field. The enclosure itself is IP67 rated, so it's technically watertight. You can submerge it up to 1 meter, but there's other electronics on the unit, so I wouldn't say that it's completely waterproof or anything like that. And then the unit will come in a Pelican case for transport, and that'll have some spares in it, and also a few different mounting mechanisms. There's those 4 brackets that you see on top that were put there for easy mounting on drones. So like the DJI Matrice 600, which is probably the most popular industrial drone on the market, just has like 2 carbon fiber poles underneath it, and those will easily clamp onto that. And then most of the other drones in the market have a similar mounting mechanism available for payloads. So it should be pretty quick and easy. There's also 2 legs, I guess they're legs, that pop out. They come down from this point, so the unit can sit flat on a table without resting on the Velodyne sensor itself. So it's a fully independent standalone LiDAR collection unit. Once you have it, you shouldn't need anything else. The only other instruments you might need to use in conjunction with this is like a long-range antenna system to get RTK corrections or to talk to your base station. And then we're working on integrating with a few micro cameras that you could just strap to the back of the unit. We have some available ports, so you could get imagery if you needed that. Yeah. I mentioned the fixed antenna offsets that open to a 1 meter separation, and we're really hoping that it's viewed as a vehicle agnostic system that you can take anywhere and use any way you like, and the system weight is 7.5 pounds. So you need a bigger drone to lift it, but there's quite a few out there that can do it. The laser on the unit is the VLP Puck Light, which is a 16 channel unit. It has a 100 meter range at the highest end of the accuracy, plus or minus 3 centimeters. It's lightweight, only 590 grams, dual return system, and it's class 1 eye safe, so you don't need any PPE or anything special to operate this unit. And then we've worked with the Velodyne 16 line for a few years at HyPACK now, so we have some good drivers for it, and are pretty comfortable working with the data that outputs from this sensor. This is our control driver for the Velodyne, where you can set a range filter. You can set minimum and maximum elevations, and an angle filter, so it'll only keep data within a specified angle, like we used to filter it to a smaller swath width on the NOAA boats, because we would pick up some noise or it would reflect off the boat deck. So you can control that and enable or disable any of the 16 channels through our driver here. And here's some specs about the Ellipse 2D. Has a 5 centimeter real-time heat filter, is RTK enabled, super small, works really great. This is a data set that was collected at the HyPACK facility, but it just gives you an idea of the accuracy that our systems are capable of. This was collected right in our front yard over an area with some grass and soil at 20 meters altitude, and it came back with an average vertical uncertainty of around 5 centimeters. So if you will note that the soil and vegetation has decent reflectivity, and that the data quality will largely depend on the surface you're collecting data on. If you're collecting data over some black asphalt, that'll have really low reflectivity and high absorption value, so you're probably going to get a bigger spread in your data. I'll show you here. So then we collected data right next to the grassy soil area at the same flight altitude over some black asphalt with low reflectivity, and the vertical uncertainty jumped up to around 9 centimeters. So it's just something to be aware of if you're beginning to work with LiDAR data. And here is a kind of blurry picture of the payload mounted to the Matrice 600, which we've been toying around with in the office. So you see that the antenna arms are below the propellers and all of the important equipment on the drone, so it won't interfere with the mission. And then the DJI also has these legs that retract up and extend down during landing, and the antenna arms don't interfere with those either, if you're interested in this specific model. And they actually, DJI came out with a new model of the Matrice that has an increased flight time and a couple other cool capabilities. So this is the back panel of the instrument. There's a little USB hub for your HyPACK key. You can also fit one of our mini keys in a USB port inside of the system, so you'd have to take off the back panel, but we have that capability. And then we have a power switch, and not pictured here, but there's a light, so you have a power indicator, so you can judge your runtime and your mission capabilities on that. And then an Ethernet port. So the way we've been working with the system currently, you can plug your laptop or just a keyboard and a monitor into the mini PC, or using the Ethernet port, and then you can initialize your mission, start logging data, and then disconnect, and then when you're done with your mission, log back into the computer using the Ethernet port to stop your mission. We're working on putting together a list of optional equipment, so if you wanted to get RTK corrections into the system or some real-time data capabilities, we have to get like a series of different long-range radio antennas. But we certainly can do that. But if you want just a real simple way to talk to the system, you can use that Ethernet port. This is some sample data Jerry collected on a trip in Canada. It was actually collected with the unit on the back of a truck, and the data set's tilted, so it looks aerial, but you can see that it picked up the edge of those power lines and the road and the trees pretty well. That's that data overlaid onto some geotiffs he collected in MDMax. You can see it lines up to the geotiffs pretty well, and picked up the extent of the trees on the lower profile side elevation pictures. Here's another image from that same data set, and you can see it picked up the surface roughness of the grass pretty well, and even the little details in that signs and those power lines pretty well. So in summary, the Lidar unit is a pretty easy to use turnkey solution. It has really versatile and portable, and we're really trying to make it as cost effective as possible. There's a lot of really nice and fancy Lidar payloads on the market, but we're trying to support our customers and keep it as cost effective as we can. So it's an industrial tool meant to work well and not break the bank. The interfaces should all be familiar with HyPACK users, and then we have the fixed offsets, so quick setup and initialization. And we're really excited about the 3-hour runtime, because hopefully it can give you the opportunity to collect a lot of data. And our data sensors are integrated tightly, so we have accuracy that hopefully should meet all your needs. And some of the potential applications could be used for, I mentioned shoreline charting for charts, pipeline mapping, infrastructure assessments, beach erosion surveys. We have some companies already using our Lidar products for that, vegetation or bare earth analysis or corridor mapping. And you're here, so you know about that. And yeah, that is it. So if you guys have any questions or want to come look at the unit at the booth and we can talk about it a little more, let me know.